I was really fond of the visual illustration of the forces in your presentation, and that you divide the phenomenon into different stages, and that was good to follow. That you explained the definition of the South Rock. But you had many unclear definitions, and the most important point is that it was very hard to follow. There were missing descriptions of variables and parameters and axes. And furthermore, in my opinion, the bubble formation is one of the key things. The experimental observation, you did the coupling over and the South Rock, and some variations of parameters, but I couldn't really follow how you changed them and how you made the experiment reproducible. Then there were missing parameters like the HCO3 concentration, the roughness of the straw, for example, so mainly on the bubble formation. Furthermore, there was a lack of documentation of the experiments, and for example, missing parameters again on the bubble formation. And we don't think that it was really reproducible because you missed many parameters. To the opponent, I think it was really good for you, that you mentioned the key element like the bubble formation, that it forms outside and inside, that you addressed the missing units on the axis, that you gave your own opinions, that we got the feeling that you really understood the problem, and you gave satisfactory answers in the clarifying questions like the bubble formation. I didn't really see why you focused on the surface tension. I think there were other points which were more relevant, and there were serious. It was an answer, a question-answer thing more, not a discussion sometimes. And the missing quantitative values, I don't really agree with you on that. So first of all, you talked about the bubble formation, and you told us that it's not relevant for the problem, and you told us that it is important, and we think this is the key phenomenon for the calculation of the buoyancy force, that we somehow should have counted it, or somehow how does the buoyancy change? And I was very satisfied with your answer that of the energy level, that how the bubbles form. The impact of the viscous friction, you told us that you don't really know how to apply it in theory, but then you both came to the opinion that it doesn't really have an effect because of the small velocity, and I agree with you. The capillarity effect, I didn't get it because the straw is pretty broad, and therefore I think it's more important that the gas it gets into the straw and pushes up the water. It is more important than the capillarity effect, and therefore I agree with the report. The definition of the linear abstract theory, this was another thing that I didn't really get, but how force per unit length, and you didn't give us a definition, and therefore I agree with the report.
First of all, thank you very much to both the opponent and the reviewer. I apologize for the quick description of the theory, and once again, thank you for the opponent for helping me clarify them. However, the bubble formations, it's a possible investigation direction, but we really do not think it's relevant. First of all, because the upward force, the data is included inside. Second of all, the question is again focused on the straw, not the bubbles. So we think that the after mentioning the upward there will be enough consideration into it already. And as we think that the viscous velocity and the capillary reflex is overall irrelevant as the reviewer does. And however, we will again improve on the experimental documentation, and also we will once again I will try to do more experiments on the parameters. Like I said in the We will also try to, although we're not sure do we agree or not, we might take into account this and see how relevant they will be as a future improvement. But I think that's it. Thank you very much.
What happened this slide? The legend shows that the green line is theory and others experiment.
Yes.
Why so much deviation?
The theory didn't account for the self-locking, which is actually a significant effect. And also, as I mentioned, other factors such as the small but here resistance and also and such. I think that's the reason for the deviation. Mostly the self-locking, the friction.
Yeah. And so, question to the reporter. So, when you reproduced your experiments, correctly? Yes. And when you did your repeats, did you use the water from the same bottle or different bottles?
Different bottles.
Okay, so you open a new bottle every time you.
What we did is that we open new bottles and then pour it into sink and then immediately dump it into the so basically add it into a first container to ensure that the volume is constant and then pour it into.
So, what volume were you using per experiment? Roughly, what volumes are we talking?
Approximately, it differs, but the range is about 300 to 370 to 1 liter, depending on the experiments we are looking at. Because again, the X% is 50% is.
To the reporter, if you do this experiment with a non-carbonate liquid like water, do you expect that you're going to see the same phenomena that you described here?
Similar difference from
How different?
for example, bubbles will no longer be less, therefore the upper force will be less, and also it affects the surface tension, which again affects the corrections here.
So is the screw going to be toppled over or not in the plain water? Have you tried it?
No, we haven't tried it.
Okay, to the reporter.
As I know, the polypropylene has little less density than water, so it should rise up. But considering that there is friction forces on the bottom of the straw and top of the glass, I don't think it will rise up if we will put it in the glass. But if there will be a big water and we will just place in the bottom of the water, it will rise up if nothing will stop it. Because it has little less density than water, polypropylene.
To the engineer said.
I think if it is standing still in the beginning, it would remain still because the bubbles formating in a normal water wouldn't be enough. There will be bubbles formating because there is still O2 and so on in the water, but it's not as much in a carbonized water.
Okay.
And then a question to the reporter, you said that upthrust, that was actually measured.
Yes.
Could you quickly explain how you did it?
Well, let me go to the slide first.
Because that photo wasn't really clear.
Oh, sorry. Basically, we measured it by we tie the three straws in such a way, and then we place the weight onto a balance, and then we look at the mass.
Okay, there must be a string going up from that straw over a pulley, then down to the straws, or vice versa?
I think, if I recall correctly, this straw is mostly just for tying them, and this is like the residue straw, if I recall correctly. If I recall correctly, yes, that's what I remember.
So, question for the reviewer. So you mentioned the dependence of the buoyancy force